All right, today we're going to be doing lesson 7, using graphs to find average rate of change, which is a Algebra 1 Unit 4 lesson, and it's on page 178 in your student workbooks. We start with a quick warm-up where we're trying to measure how quickly the output of a function changes. So remember that this is kind of like an XY table where X is the input and Y is the output. Or now that we're talking about functions, we have our input and then we have our output f of x. Anyways, we're looking at the change of temperature over time. Tyler says the temperature dropped faster between 4 and 6. Mai says the temperature dropped faster between 6 and 10. And pause the video here and calculate those differences and see who you agree with. All right, hopefully you did a subtraction and you noticed that this one was going down 8 and this one is going down 9 degrees. So on a quick glance, you might say, oh, it looks like Mai is correct then because it's going down more. But remember that when we're looking at the change over time or the average rate of change, we need to also consider how many time and hours is passing up at that top input variable. So we're looking at the change in the bottom, but we're also comparing that to the change in the top. Notice that 6 minus 4 is only a 2-hour time span, and 10 minus 6 is a 4-hour time span. So if we're looking at a change of -8 over 2, Tyler's change is about an average rate of change of down 4 degrees per hour. That's our reduction, our reduced version. And then Mai says that it's going down 9 degrees, but that's over the span of 4 hours. So grab your calculator, and 9 divided by 4 is 2.25 degrees per hour. So our initial feeling is actually incorrect, and Tyler is actually right. Tyler, who said the temperature dropped faster between the first 2 hours, 4 and 6, is correct because it is a greater average rate of change. The drop was bigger. All right, now we're looking at a more detailed table of this increase and drop in temperature. So the table and graph shows a more complete picture of the temperature changes on the same winter day. The function T gives the temperature in degrees Fahrenheit. And then the H is the hours since noon. Notice hours since noon is our independent variable, our X, or our input. And notice temperature in Fahrenheit is our output. So find the average rate of change of the following intervals. When we're looking at this, or an interval, a little section, we're going from noon, which is the starting point here. Our 0 is our time noon, or hours since noon, notice down here. So if we're going from noon at time 0 to 1, we're just looking at this little tiny interval right here. This section from 0 to 1. So what was the change in that small section? Well, it went from here to here. So how are we counting on the side? It looks like we're counting by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. So it went from 18, what would you call that next one, to 19? So we just do a subtraction. What is 19 minus 18? And our average rate of change is just 1 degree. How about from noon till 4? So this is a 4-hour time span, so we have to divide over those 4 hours, and let's go look at what those are. So from noon, the 18, till 4, let's see, 20, 22, 24, I'd say that's like around 25. So this time it's going from 18 to 25. So we're going to subtract those. And 25 minus 18 is 7. 7/4 can be reduced down. Grab your calculator to 1.75 degrees. That's our average rate of change in temperature. Pause the video and try from noon to midnight. All right, let's see how you did. So from noon to midnight, this is now a 12-hour span. And we're going from that starting 18 all the way to here. This is going to be a downwards. And it looks like around 7 is where that one is hitting. here in between the 6 and the 8, this guy right here. And so if we're going down from 18 to 7, this time when we subtract, we're getting a negative rate of change or slope because it went down. So 1 degree, 1.75 positive degrees, and then negative 11/12 degrees. Could you divide that and get something like negative 0.9? Yes. Remember my and Tyler's disagreement? Use the average rate of change to show the time and period. So now I just want to bring you back to a good old formula that you maybe remember from middle school called the slope formula. And so what we've been doing here to get these average rate of changes is we've been doing the change in y over the change in x. Does this look familiar? And so let's go back and formally do Mai's and Tyler's scenario. And so going back up here, Mai was saying between 6 and 10. So we're going to use these two x values and these two y values. So for hers, it's going to be 8 minus 17 over 10 minus 6, y minus y over x minus x. For Tyler's, he's doing between 4 and 6. So we're going to use these x's and y's. 17 minus 25 over 6 minus 4. Now notice we are going down in temperature, so we should get a negative. Negative 8 over 2, also known as negative 4. So notice that, I think we got negative 2.25 when we divided this. Notice we got negative slopes. This is known as the average rate of change. And we're supposed to link this to the slope formula that we were using in middle school. Feel free, if you're ready for more, to do these two questions. Finally, we're going to look at the population of two states. This graph shows the populations of California and Texas over time. Notice that California is the blue solid line and Texas is the dashed red line. It wants us to compare between 1970 and 2000. This is called an interval, and it only wants to look at this interval of how those populations were increasing. So starting at this point here and going to this point here on the dashed line, starting at this point here and going to this point here on the solid line. For me to do that average rate of change, I need to get these coordinates. So this first one is at 1970 on the x-axis under years, and it goes up to a 20 on the y-axis. Do you see how that is the coordinates of that point? Over here we've got 2010, and what do you think that is, like 38, 37, whatever you want to call that? That's like an estimate right there, because it's not quite hitting a corner. Now I have an x1 and a y1 and an x2 and a y2 to plug into the average rate of change formula. This is going to be for California first. So we're going to go 38. Do you guys think that's at 38 or 37? I don't think it's quite at 38. I'm going to call this 37. Again, if you put 38, I would have been okay with it. So 37 minus 20 all over x2 minus x1. So we're doing the formula y minus y over x minus x. Notice it's a positive increase in population, and I'm about to get a positive answer. I'm going to get 17 over, how many years is that? That looks like 40 years. So when I divide this, 17 divided by 40, I get a population factor of 0.43 or 0.425, if I don't round, of positive increase in population for California. All right, I'm going to go do the same thing right now for Texas, the dashed line. What does that look like? That point right there is at 1970, comma, it's above 10. Would you call that 11? And this one's at 2010, comma, I think it's landed in the middle that time, 25. Now I have my X1, my Y1, my X2, my Y2, so I can get the rate of change by using the average rate of change formula. So here I go. I'm going to go 25 minus 11. And hey, the denominator is going to be the same, 2010. We're still looking at the same interval. So this is going to be 14 over 40. Let's divide and see if that's bigger. Notice it's still a positive increase in population, like a positive slope of the graph. So for California, I got 0.425. And for Texas, I got 0.35. Which one's increasing faster? Well, welcome to the real world. It is California. Okay, in this situation, what does each rate of change mean? Well, that little 0.425 answer that we got means that California, our population is increasing at a rate of 0.425 during those years. Let's say which years. Okay, and it means that Texas population is increasing at a rate of 0.35 during 1970 to 2010. Which state's population grew more quickly between 1900 and 2000? So now we're going on a different interval here. I'm going to use pink. So from 1900, way back at the beginning, to 2000, look at that huge change. And then from 1900 to 2000, which one went up the most? For sure, California. We see on the graph that the line went up more, the solid line, now, could we do an exact calculation and get an exact change, like how much it went up? Yes, we could. All right, make sure to go through and highlight the summary now, but let's now link this to our function notation that we've been learning. In middle school, we used the slope formula, and now in Algebra 1 in high school, we're going to use the average rate of change formula for our function. And so what does that look like? The function that used to say, oops, that's not very dark. Y2 minus Y1 over X2 minus X1 is now going to get put into function notation. The output of B minus the output of A over the input of B minus the input of A. And this is now our grown-up Algebra 1 function notation for the average rate of change. Used to be known as the slope. Still the same. Okay, how'd you do? Please make sure you highlighted that.